Hi, this is Randy with Sophos Tutor, and I just want to say a quick thank you for clicking on this video. Also, if you haven't already, please click subscribe to Sophos Tutor, as it really helps out with the channel. Thanks. Okay, so this question comes from the 2019 AP Calculus AB free response portion of the test. And this does require a calculator. So when doing calculator questions, it's critically important that we know how to set up the problem. You're not going to be expected to literally take a derivative or take an antiderivative. You will be expected to know what you're taking the derivative of, what you're taking an antiderivative of, and know how to enter that into your calculator. Expecting most students will have TI 83s or TI 84s. So if you do need to learn how to use a TI 83 or 84 and how to take derivatives, I strongly suggest you look up a video on YouTube and how to do it. What I'm going to be going over here is just what you need to enter into that calculator. All right? So the question starts, fish enter a lake at a rate modeled by the function e. And we have this function e equals 20 plus 15 sine parentheses pi t over 6. Should be noted that this should be in radians. Okay. It also says that fish leave the lake at t, or rather L of t, equaling 4 plus 2, 0.1 t squared. And it says that both e of t and L of t are measured in fish per hour. So both of these functions are in fish per hour. It's really important that we know how to note the units, because by noting units, we can determine whether we should be taking derivatives or antiderivatives of this function. Okay. And t is measured in hours since midnight. Right, and so t equals 0 is midnight. So before we go on to A, B, C, and D, let's talk about what this unit fish per hour tells us. When we take a derivative of a function with these units, the unit of the derivative of the function will be in fish per hour squared. Notice that we're going to multiply an extra hour unit in the denominator. Now, if we take an antiderivative, right? So the antiderivative of, in this case, et minus lt dt, what we'll get is a unit of fish. Okay. So note that if e of t minus L of t, if this is equal to the net rate of change of number of fish, then that means if we take an antiderivative, if we take an integral of this function, we should get something involving the number of fish here, because our unit's in fish. If we take a derivative of this function, we should get the rate of change of the rate of change of fish. Okay, so this is how much the rate is changing. This is how much the number of fish is changing. Now that we have this set up, now let's go ahead and tackle part A. Part A says, how many fish enter the lake over the 5-hour period from midnight? So we care about e of t, from t equals 0 to t equals 5. Well, if we want number of fish, then, as we've said, we are going to take an integral, right? Because that's number of fish. In this case, we only care about e of t. So 20 plus 15 sine of pi t over 6 dt. And our numbers are going to be from 0 to 5. Okay? So literally all you're just going to do is just put this into your calculator. Now I know under the TI-84 calculator, I believe the function you want to get is fn int. That's what you're looking for. Okay. And then you're just going to plug in your values for x, etc. Of course, also make sure that you are in radians, again for sine. Okay. So that is part A. Part B. What is the average number of fish? Okay, so we want an average number of fish that leave the lake, per hour between t equals 0 to t equals 5. Okay, so whenever we see average, we need to translate this to total divided by time. Okay. So in this case, the average per hour isn't an average of the rates, it's an average of the total number of fish divided by the total time. So what is the total number of fish that leave? Well, remember, if we want number of fish, we need to take an antiderivative. So we're going to take an antiderivative from 0 to 5, in this case, of our L of t function. 4 plus 2 to the 0.1 t squared dt. We're going to divide this by the total amount of time. Well, how much time was taken? Well, we took 5 hours, so we'll just divide this by 5. Okay? And this is what you're going to enter into your calculator. So now part C. At what time t between between 0 and 8 is the greatest number of fish? And we need to justify our answer. Okay. So whenever we see a word that's asking for the maximum or minimum, right? It's indicated whenever we see a word that ends in est. We call this the superlative form of the word, right? Greatest, longest, shortest. We know that this is a max-min problem. Okay. If we recall, how do we find the maximum or minimum of a function? Well, we need to compare values, right? So we compare. First of all, we can compare critical points. And we remember that we find critical points by setting the first derivative equaling 0, or if it's undefined, right? And that will give us our t values, and we can plug them into the function, right? Or we could also use an endpoint. So if we know the values of the endpoints, then we can figure out the if it's a max or a min, right? We can just compare these values. So then how do we find a critical point? Well, in this case, we want the greatest number of fish, which means we need to take the derivative of the number of fish. Well, what's the derivative of the number of fish? Well, fish is here. If antiderivative is going to the left, then the derivative is going to the right. So the derivative of fish is this equation, et minus L of t. So in order to find the proper number of fish, or rather the critical point here, we need to set e of t minus L of t and set that equal to 0. And from there, we can then determine what t is equal. Now, I would strongly suggest that we graph this function. okay? So in your calculator, you're going to go into the y equals portion, and you're going to enter 20 plus 15 sine of pi t over 6, okay, minus parentheses 4 plus 2 to the 0.1 t squared. You're going to enter that into your function, and then you're going to use the tools on your grapher, right? Either the calc function or the zero function to determine what your t is. Now, I did pre-solve this problem C, and I'll give you a moment to figure that out. Okay, if you want to pause the video here. Okay, so the solution that we get here for where this is equal to 0, this rate is 6.2. Now, we haven't determined whether this is a max or min yet. And we also don't know what this original function of fish really is. So how could we determine if whether this is a max or a min? Well, we remember that according to extrema value theorem, right? Extrema value theorem, we know that we have a max where a derivative is equal to 0 if this derivative is greater than 0 at values less, or we know if it's greater than 0 if the function is greater than 0 before t is equal to 6.2, right? When t is less than 6.2, and f prime of t is less than 0 when t is greater than 6.2. Right? Because remember, the derivative determines whether a function is increasing or decreasing. So if the function is increasing before t equals 6.2, then we know the function is going up and up and up and up until we get to 6.2, which we know the derivative is equal to 0. And then if we know if the function is decreasing that whole time, well, we know that the function will be less than the value at 6.2. And if we look at the function, at this graphed function, we're going to see that the function is going to look something like this. It's going to look something like this, and the function is going to come down. And this point right here is 6.2. Right? Because the derivative is a positive in this area, we know that the function is increasing in this region. It stops increasing at 6.2, and then it decreases, and it just keeps going downwards, which means we know that the maximum has to be at 6.2. And so we can say that's maximum because of extrema value theorem. Okay. So to summarize, we need to determine that et minus L of t is the derivative of the number of fish. To determine maxes and mins, we set this rate to 0. And then to determine if this point is a max or min, we need to see if this derivative is positive before we get to 6.2, and if it's negative after t is 6.2. And looking at the graph, we see that indeed the derivative is positive before 6.2 and negative after 6.2. So we know at 6.2, we know that we have a maximum. And that's part C. Right. Okay. Part D. Is the rate of change of fish of the lake increasing or decreasing? Okay. So it's asking for rate of change of fish. Okay. Is it increasing or decreasing? Now, the simple way that I think of is whenever we're determining if a quantity is increasing or decreasing, we want to look at the derivative of that thing. Is derivative of this thing, which I'll put a star of, positive or negative. Okay? So we need not the rate of change of fish, but the derivative of the rate of change of fish. Well, we know that E of t minus L of t is the rate change of fish. So we need to actually take its derivative. So what we need to do is we need to write a derivative of, in this case, we'll write the full function out, 20 plus 15 sine of 5t, oh, sorry, not 5t, pi t, start over. If we take the derivative of 20 plus 15 sine of pi t over 6 minus 4 plus 2 to the 0.1 t squared, okay? And somewhere in a calculator, you should be able to say that t is equal to 5. And so if you put this in your calculator, if it's positive, then rate of change of fish is increasing. Okay? If it's negative, then the rate of change of fish is decreasing. Okay? So the problems here don't take very long to solve, but you see how important it is that we're very clear with our definitions. You see that lots of different functions can be considered derivatives, so you have to ask yourself, what am I taking the derivative of? And whenever I take the derivative of something, that new thing that I have is a description of the rate of change of the original function. So this E of t minus L of t is a rate of change of the number of fish. The derivative of this, the derivative of E t minus L of t, is the rate of change of E t minus L of t. And you see how we have to solve that for D and determine if that derivative is positive or negative. And there you go. Okay. Thank you so much for watching. Now, if you liked what you saw, please click the thumbs up button below. Also, if you want to watch more of my videos, or you want to catch me on an office hours live stream, please click subscribe to Sophos Tutor.